open a website, the security story does not stop at the padlock icon in your browser. There is a quiet layer of rules that rides along with every page, telling the browser how cautious it should be. Those rules are web security headers, and they are the focus of this Tuesday Insights feature from Bare Metal Cyber Magazine. Think of them as tiny configuration choices that can make a big difference in how safely your site is handled across millions of everyday visits. Web security headers are simple instructions that a web server adds to each hypertext transfer protocol response. Along with the page content, scripts, and images, the server sends a collection of headers that guide the browser's behavior. They can tell the browser to only use encrypted connections, to refuse to run scripts from unknown locations, or to block the page from being displayed inside a hidden frame. None of this is visible to the user, but it quietly shapes how much risk they are exposed to.
These headers sit in the delivery layer of your web stack. They live between your application code and the user's browser, often configured on the web server, reverse proxy, or content delivery network. In many organizations, they start as lines in a configuration file, then become part of shared infrastructure templates. That makes them more than a technical trick. They are both technology and process, because someone has to decide which headers are required, how strict they should be, and how they will be kept in step with ongoing development.
It helps to anchor the idea in a few concrete examples. A header like HTTP strict transport security tells the browser that your site must always be reached over secure HTTPS, even if the user clicks an older HTTP link. A content security policy header defines which sources of scripts, images, and other resources are trusted, closing off many paths for cross-site scripting. Framing headers like X-frame options or more modern frame control directives block your pages from being silently embedded inside hostile iframes used in clickjacking. Each one pushes the browser towards safer defaults. From the browser's point of view, every page load starts with a set of decisions driven by these rules. When a user visits your site, the browser receives the response, reads the headers, and then chooses how to render and interact with the content. If strict transport is enabled, it remembers that and refuses to downgrade to plain HTTP later. If a tight content security policy is in place, it checks every script and image against the approved list before loading. The browser becomes an enforcement partner instead of a passive display tool. A simple journey helps illustrate this. Imagine a new visitor reaches your login page over HTTPS. The response includes a strict transport security header and a content security policy that only allows scripts from your own domain and a known content delivery network. The browser caches the transport policy, so future attempts to reach your site over plain HTTP are silently upgraded or blocked. At the same time, if an attacker sneaks in a script tag pointing to a shady domain, the browser refuses to run it because it is not on the approved list.
These benefits depend on a few important foundations. Your site needs to support HTTPS correctly and use valid certificates. Proxies and content delivery networks must pass through or apply headers consistently. Your team needs a small but real testing process, especially for complex content security policies, because a mistake can break legitimate features in subtle ways. Web security headers are powerful, but they are not magic. They sit on top of basic hygiene around identity, encryption, and deployment. In everyday work, you see web security headers show up as part of standard hygiene checks. Security reviewers look at them during application assessments and penetration tests. Operations teams bake them into standard server or proxy configurations so that every new site inherits a baseline automatically. Over time, organizations treat them like patch levels or minimum TLS versions. They become one more checkbox that must be satisfied before a service is considered ready for the internet. There are clear, quick wins that almost any team can pursue. If your public sites already use HTTPS, enabling strict transport security is often a low-risk, high-reward step. Adding X content type options reduces the chance that the browser will misinterpret a file and execute something it should only display. A careful refer policy helps limit how much sensitive path information leaks when users click from your site to others. Basic framing protections protect high-risk pages like logins, account settings, or payment flows from being wrapped in deceptive interfaces.
Beyond quick wins, mature teams use web security headers in more advanced ways. They craft content security policies that forbid inline scripts, require nonces or hashes, and tightly constrain third-party sources. They tailor headers to different parts of an application, keeping them especially strict around authentication and account management, while allowing carefully controlled flexibility in rich dashboards. They also link header work with broader initiatives, such as reducing attack surface on a customer portal or standardizing security patterns across multiple products. The upside of all this effort is significant. Once configured, headers harden every response without adding new agents or user-visible friction. Strict transport rules cut off downgrade and mixed content risks. Framing protection reduces clickjacking opportunities. Thoughtful content security policies make it much harder for injected scripts to run quietly in the background. For the cost of some careful design and testing, you gain a layer of defense that follows every page and every user. At the same time, the trade-offs are real. A strong content security policy has to keep pace with how your application evolves. New features, third-party services, and changes in front-end frameworks all affect which sources and patterns must be allowed. If policies are locked down without regard to reality, features break and developers quietly work around them. If they are too generous, they give a false sense of security while leaving many paths open. Maintaining the right balance takes ongoing collaboration between security, development, and operations. There are also hard limits to what web security headers can solve. They only apply where a browser both understands and enforces them. They do nothing for direct API calls from back-end systems or from mobile applications that do not honor them. They cannot repair broken business logic, weak authentication, or missing authorization. A site with bad access control and exposed admin functions is still fragile, no matter how polished its header configuration looks in a scanner report. Common failure modes tend to look the same across organizations. One pattern is set and forget, where headers were added long ago, never reviewed, and now bear little resemblance to the live application. Another is copy and paste, where teams lift example policies from guides or other sites without understanding them. The result is either overly permissive rules that pretend to be strict, or policies that are so restrictive that they silently push developers to disable or bypass them. Relying only on automated scanners is another subtle trap. Tools are good at spotting missing headers or obvious weaknesses, but they cannot judge whether your settings make sense for the application's design. Shallow adoption looks like having headers present, reports that say pass, but recurring findings for cross-site scripting, clickjacking, and other issues that those headers were meant to mitigate. In that world, headers exist on paper, but are not actually part of how the organization protects itself. Healthy adoption looks much more intentional. Someone can clearly describe which headers are required for each class of application and where they are defined. New services inherit a baseline automatically through templates or infrastructure as code. Changes to headers flow through the same review and test paths as changes to the application itself. When new features or third-party components arrive, updating the relevant policies is treated as a normal part of shipping, not an afterthought. These are the signals that headers are doing real work, rather than just satisfying a checklist.
At its heart, the idea behind web security headers is simple. Teach the browser to act as a more disciplined partner in defending your applications. By adding a compact set of rules to each response, you shape how transport, content, framing, and refers are handled in ways that benefit every user with no extra effort on their part. When you treat headers as part of your standard build rather than an optional add-on, They lower the noise level and shrink entire classes of preventable issues. As you think about your own environment, it can be helpful to frame headers as a focused layer in your defense-in-depth story. They sit at the delivery edge of your web stack, complementing work you already do around patching, identity, secure development, and monitoring. A short review of your public-facing sites and key internal portals can reveal where easy gains are still available. From there, small, deliberate changes to your header strategy can give you a stronger foundation to build on, turning those quiet configuration settings into consistent, everyday protection.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.